Hi, my name is Jonathan Wynn, and this presentation is a complete how-to guide for the exact Pi-hole deployment that I use on my home network. The router I'm using is a Netgear Nighthawk RS200. It's running firmware version 1.0.6.16, and the server is a Raspberry Pi 5 that already has Raspberry Pi OS installed and connected to Wi-Fi. The goal of this guide is that my Raspberry Pi keeps a fixed address of 192.168.1.122. Pi-hole will then run on that address and act as a DNS sinkhole that I can use to filter all the network traffic that comes through and block ads on every device connected to my Wi-Fi. After this walkthrough, the router will stop serving IPv4 DHCP. Pi-hole will begin serving DHCP to the rest of the network instead. After I renew the connected devices' connections, their DNS traffic goes through the Raspberry Pi first, which will allow Pi-hole to filter requests and lets the dashboard show the individual client devices. The order matters. I will first verify the router settings and then identify the active network profile on the Raspberry Pi. Then I'll assign the static IP address that I reserved on my router to the Pi. Then I'll install Pi-hole. From there, I'll stage the DHCP settings, and only after that will I switch DHCP from the router to Pi-hole. That sequence avoids taking the entire network down accidentally while I'm still configuring the server. Just as a note, I have already separately configured Tiger VNC to connect to my Raspberry Pi so that I can execute commands via terminal in this remote view window. So Pi-hole is easiest to understand as a DNS filter. So a client device does not connect to a website by name directly. First, it has to ask a DNS server to translate the domain name into an IP address. Pi-hole will sit in that position. So if the requested domain is on a block list, the Pi-hole does not return a normal answer, so the ad or tracking endpoint never resolves correctly. If the requested domain is allowed, though, Pi-hole will forward the request to an upstream DNS resolver, receive the result, cache it, and return it to the device on my network that requested it. And that's why Pi-hole can improve privacy and then speed sometimes as well. For this specific router, the DHCP feature is important. For this project, I want to talk directly to Pi-hole for DNS, so the dashboard shows the individual devices on the network and not just the router. That's why I use Pi-hole not only as a DNS filter, but also as the DHCP server for IPv4 later in the process. So these are the exact values that I use all the way through the walkthrough. The router is at 192.168.1.1. The subnet mask is the default of 255.255.255.0, and the Pi that I'm using is 192.168.1.122, and that's the static IP address that I've given it in my router settings as well. The Pi itself will continue to use the Cloudflare resolvers 1111 and 1001. That way, the host doesn't depend on Pi-hole for its own DNS before I finish installation and validation. So I also preserve the DHCP range from 192.168.1.2 through 254. Long term, if I were to run this all the time, I would exclude that Pi address from the DHCP scope as well. But for this presentation and demo, I'm just matching the actual commands and values from the initial environment I configured, doing this the first time. So what I'll do is I'll start with the router settings here. I'm probably gonna have to log in again. Yeah. So what we want to do here is just verify the existing configuration that's already in here. So we'll go to setup, we'll go to LAN setup, and just confirm 192.168.1.1, 255.255.255.0, and then if we scroll down, there's the starting and ending IP address range for DHCP, and there's the address that I've reserved for the Raspberry Pi. This box is important. We do not want to uncheck this yet because we do not have the Raspberry Pi configured yet to take over. So at this point, we want to identify the network manager profile that's controlling the Raspberry Pi's Wi-Fi connection right now. I do that before I change the address because network manager saves configuration by profile name. So what we'll do host name I, and that will show that's the static IP that I've assigned to it. We'll do nmcli device status just to confirm that we can see the Wi-Fi. WLAN 0, it's Netgear 345G, and then we'll go nmcli connection show active, and that will show us the exact active profiles that are saved in here. And this is important because we can see the actual name in here. It is case sensitive when we're assigning those values later. So what we'll do now so this command here, this is where it's going to just make sure everything is assigned correctly for the Raspberry Pi. It's considered one long command in here because of the backslashes, so it knows that it's, even though it's on a new line, it's on the same line. So that first one there, nmcli connection modify, that tells Network Manager to edit the saved Wi-Fi profile, named Netgear 345G. The next one here will stop that profile from using DHCP for IPv4. This will assign the fixed address 192.168.1.122/24. This will set the this will point the default route at the router itself for the IPv4 gateway. This is telling it to continue using the Cloudflare DNS. And then the last one here, IPv6.method auto, just make sure that the IPv6 address assignment is unchanged. So from here, what we're going to do is run sudo reboot. This will reboot the Raspberry Pi. So it will terminate the connection that I had here with the remote viewer, but it should come back up here in just a moment. There we go. So from here, what this does here, this command nmcli-g ip4.address and ip4.dns connection show, it reads the saved address and DNS values from the profile. And then hostname I here shows the live address currently assigned to the machine. So at this point, you'd expect to see whatever IP address that you assigned there previously. From here, you would then run these three commands to update the Raspberry Pi OS. I've already done this. I know that mine's up to date completely, but you would just run sudo apt upgrade, apt full upgrade -y, and then reboot again. That would automatically install all the upgraded packages and dependencies that you would need. At this point, it would be good to go ahead and install Pi-hole. So you would just run this curl command right here. And then it has a little automated installer that'll pop up here. So you hit OK, we hit OK, and it says it is a server, so it needs a static IP address. So we'll just hit continue because we've already done that. And then we'll select the Wi-Fi, and then we'll go to Cloudflare for our DNS provider that we set earlier. And then we'll choose the just default block list. And this is just going through and installing all of the dependencies that we need for this. Okay. So it would give you your admin password there, but what we want to do is, like it says up there, where we're going to run oh, yeah. For security, it doesn't actually show you what you are typing whenever you type in your password stuff. But so I got my password set there. And now what we're going to do, I'm going to add my user profile to the group. So group membership is fully applied. And we are going to do reboot this one more time. All right. So from here, I'm going to go ahead and open up the built-in web browser. It's going to ask for your password. That will unlock it, and we'll go here. And what this shows is the actual interface for the Pi-hole. So if I had this active and there were a lot of devices going, you would start to see queries going, queries blocked, percentage blocked, and then that's all the domains that are on the domain list. But what we're interested in right now is we want to go to settings, we're going to go to DNS, and we're just going to make sure this is what we want right here. We want to make sure the interface binding mode is set for a normal home network deployment. So allow only local requests. Yeah. So we're good there. So we can close out of that. And then what we'll do is we're going to run sudo pi-hole status. So Pi-hole blocking is enabled. So that's all good there. So we've got that set up and configured. So now on this slide, I was just that was just going over what I had talked about right there with the admin interface and going in there. So now we want to configure the actual DHCP settings, but we don't want to enable it yet. So each of these commands is going to write a single parameter into the FTL configuration for this. So we're just going to put these in one at a time. So that is going to set the start and end of our DHCP pool. This is going to set the default gateway, which is the router. This is going to set the subnet mask. That's going to set the DHCP lease time. And that's going to set the Pi-hole DHCP server as disabled. So this is important because we don't want to turn this on and then have it on the router itself as well. So we don't have any overlap right now. So now this is the handoff stage. So what we'll do is I'm going to log into the router once again, probably. Yeah. Oop. And we'll go to advanced. We'll go to setup, LAN setup. We're going to uncheck use router as DHCP server. When we do this, we will probably lose connection to the Raspberry Pi. So that is okay. We're going to hit apply. I'm going to cut over right now to a different monitor. But now I'm over in the terminal on the Raspberry Pi once again. I'm going to go ahead and type in sorry, I was having an issue there with my keyboard. Sudo pi-hole ftl config dhcp.active true. So that will turn on Pi-hole's embedded DHCP service, and then sudo systemctl restart pi-hole-ftl.service. And then finally, sudo pi-hole status once again. Looks like everything is enabled correctly. So now, I'm going to cut back over to the screen that I was on. There we go, perfect. So now you can see these are the commands that I ran. So there, there, and there. So now on my actual desktop machine here, because it doesn't automatically update the lease, I'm going to go ahead and run ipconfig release, and that's actually gonna kill that connection. And then I'll do ipconfig renew, and that will update that, give it a fresh DHCP lease. So now I should be using the Raspberry Pi as the DNS server. So right here, connection specific DNS suffix LAN, default gateway. Okay. So let's take a look. Yeah, check it out. So now we have Pi-hole active. These are the domains that it's blocking, and you can see there are actual queries coming in live right now. It's blocking queries. And what we can do, so I'm just going to make sure everything's updated, so we'll do sudo pi-hole update gravity, and then sudo pi-hole tail. And yeah, so I have people in my house that are using Netflix, watching things on their, using their phones, that kind of stuff. And this is all the network traffic that's coming through that it's filtering. See, and we can see there it just blocked Netflix ad. So from here, we'll type ipconfig/all. And the DHCP server is the IP address that I have as, assigned to my Raspberry Pi. So we know that it's working. So that is pretty much it. I appreciate you guys watching, and I hope you found this this guide helpful and informative. Thanks.